All right, Friday night, and it's time for another coding challenge. So let me quickly check if everything works fine. Yeah, seems like that. So this stream is for entertainment purposes only. We will try to crack another coding challenge, coding problem under 40 minutes, hopefully, maybe not. So let's see what we've got today. Problems. Pick one. Nice. Another medium problem. We have a two-dimensional matrix A where each value is, okay, binary, 0, 1. A move consists of choosing any row or column, all right, and toggling each value in that row or column, changing all zeros to ones and all ones to zeros. Okay. After making any number of moves, every row of this matrix is interpreted as a binary number, and the score of the matrix is the sum of these numbers. Interesting. Every row is a binary number as a result, right? We can choose either row or column. All right. So, I see. 0011, 1010, 1100, output 39. So we can change it all once in the first one. Change all zeros to ones and all ones to zeros. So basically you flip it, right? So we're flipping what, the column? That's my understanding. So how do we make the first row all ones? The only way is we basically flip first two columns, right? So 0 becomes ones, and this becomes 0 and 0. And then we can flip the entire arrow there. And this becomes 1001. But why this remains the same? This is changing. All right, I got it. So it was 0, 1, 1, 0, and then we flip it again to make it 1, 0, 0, 1, because this obviously bigger number, right? That's what we want. Okay, so the largest number in the row, if all ones, is what is, so this is 2, 4, 8, 12, 14, 15, right? And if all zeros is 0. Okay, I see. And then we get 39. All right, and we need to find the maximum one by doing these operations, which is so the goal basically is to make as much ones in the row at the beginning as possible. All right, so the further one in the row, the lower its impact on the score. All right. So let's switch to the whiteboard. See, it's somewhat similar to the one I solved yesterday, to some extent, but let's see. So let me write this example down and see if there is any algorithm that we can use to redo. That's written here. So we can turn this to sorry. In this one, once we flip this column and this column, right, this becomes all zeros, then we flip them, it becomes all ones. This becomes 0, 1, 1, 0, then we flip it, it becomes 1, 0, 0, 1. And this is somehow is maximum. So is it the same first just to maximize number of rows by flipping columns to make them equal? And then just go through rows that are no O zeros or O ones, because we know that each row will be whatever number it is, right? And then see if by flipping and just basically for the rest we can select the value. Okay, let's do this then. So the algorithm will be the following. We first maximize, but does it guarantee us the optimal value all the time? So when they say the maximum, it's always like the highest possible score. How do we know if it's the highest possible score? So what if it's vice versa? What if we start flipping columns by columns to check first how many ones we can get here? Because obviously we want to first maybe maximize the number of ones here before maximizing number of ones here. Interesting. Maybe that's the reason if we want to flip the row. But on the other hand, if we make all zeros in a row, we can just flip it to all ones, right? And all right, let's find max rows 0 or 1, because they all cost to the max number, right? And for whatever left, second, flip if maximizes the number, which is basically all it does. We just go and check the first one. If it's 0, we flip the row. If it's 1, we keep the row, because it's obvious, right? All right, so then the rest will be the same. So okay, assuming it's the right way of finding the maximum, because to me it's always not clear whether it's the maximum, because to me it sounds like, okay, the maximum number, yeah, I think if we first maximize the number of rows that we can have zeros or ones, or zeros or ones, because then we can convert these rows into the all right. Okay, let's do this and see if it works. So basically, let's switch back to the default scene. I think it will be like yesterday. So vector of what? Of string. All right. What it was? Oh, once. Right. It's a size. Of zeros. Point I less than. So to go here, we'll first try to maximize number of. Not sure if it's the right way, but maybe it's okay to do this, and it still will yield us the optimal solution. So we'll first try to maximize the what? That was on set of int zero. So we go here first and say if ij equals 0, zeros insert and j, and then oops. What the heck? All right, and here then we have string 0 key. We don't need this actually. So all we need is just to check if do we really need it? No, we don't. I think all we need is just do this. We don't need this thing. You don't need this thing. So we say all zeros I plus equal to string j plus whatever separator we have. Right, else we have once, right? Because if not 0 means it's 1. Now unordered map of string integer unique keys, right? So we say for we can say basically this, because we know that this is the same. Instead of a, we can use whatever is there. We say what unique keys of all zeros I plus plus. Same thing for all ones plus plus. Once we need string max key, right? That's basically the combination of columns we flip in order to make the decision. So the only thing I don't like here is that now we need to parse string back to make but I doubt we can use vector as a hash gun. But whatever, we can always split it with this sign we have, right? All right, so then we basically go for const out whatever key, cnt, unique keys, right? So here we have in max key cnt equals 0. Obviously, if max key cnt less than cnt, we say max key equal key, max key cnt equal to cnt. All right. Now count all rows to be 1, to be all ones. So this is our first step. I mean, aside from the fact that we need to do this. So in this case, all we do is just we go through this thing one more time. Check if max key equals what? O1's I, or it can be O0's I, because if it's O0's we can flip it to O1's, right? So it doesn't really matter. Then let's just have here namespace what int, let's call it to binary to int, and we'll have this vector int as const reference binary so we can start int num 0, right? So 4 whatever here, so binary size. So here we say that num plus equal, so it's linear time to compute the number, but I think it's fine because it's anyway quadratic complexity here. So we say what? We say, oh gosh, for 2. So if we have, let's say in this example 4, but it's really, so 2, 4, 8, so it's 2 to the power of 3, meaning that it should be binary size -1, sorry, minus I, right? So if it's 0, it will make, and it should be -1 as well, I guess. So here we go. And obviously we need to multiply it on binary I. So if it's 0, it remains 0, so we don't add anything. If it's 1, that we add power to this. So if I equals size -1, it will make 2 to the 1, which is 1. And if the last element is 1, it adds 1. If it's 0, it adds 0. So okay, yeah, makes sense. Return none. All right. So what we do here, basically we don't need to do this, but okay. So we can just say directly, but all we do is just say that I j equals 1, right? Because we can do this because our key allows it to make either O zeros or ones. If it's O zeros, we have ones. But no, so we already checked for that, so it's okay. Now, and then we say total in total equals 0, total plus equal to binary to int, I, right? Okay, it's easy. Else, this is more interesting. So if we can make it as whatever, we should now parse the into numbers and then and oh man, I guess it's str split, string split, cpp example. Let me see if it's an easy one. All right, so it's not easy. Seems like. Is it simpler way like string split or something? All right, so it seems nice. Okay, let's have another function here, which will return vector of int. Let's call it key to index, right? So let's see, we have this const, or maybe we don't want const. Okay, let's just have string key. So we'll do this once anyway. We have this. So we okay, size position string whatever here. Yep, we don't need to do this. Okay, position token. Let's say we know the token equals to this thing. All right. It should be delimiter. So it's not this. It's a delimiter. Right. Yeah, I didn't know it would be that not easy, I would say. All right, so let's done with this token, whatever. Let's just say here, just in case. So we have this token, which is the part of this string, right? So then we say, and it should end with this thing, right? So we don't need this technically. Delimiter length. So once we have token, we need to convert. Okay, in string to int cpp. I think this should be easy conversion. S to E. So we say what we have this vector of int and this is indices. Okay, whatever. Let's see. So we say just int push back story of token. Right. Here we go. So all we need to say is this vector of int key indices, and basically say it's equal to key to index. Here is max key, right? So here we go for basically just we can say in J in key indices, right? We first do what? We first flip ij equal to what? Ai j. So if it's 1, we flip it to 0, otherwise if it was 0, we flip it to 1, right? Then we say int num1, which is equal to what? To binary to int ai, right? And then we go and reverse it completely, right? Which is just this, and then we do again this, so we reverse it one more time and have what? Num2, and then we say total plus max between num1, num2. All right, and then once it's ended, we just return total. 33 minutes. We still have 10 minutes to debug it approximately. And code is ugly, but let's see if it runs at least. Oh man. Yep, it's not S. It's not S. It's key. Oh, we can call it S. Who cares? Yeah, because we do not return anything. Oh, nice, it works. At least it doesn't fail. But it says 37. So I wonder which row we flip. And right, let's just see. Okay, see out. Row I all ones, and then we say no ones, a binary equal to no. Right, so maybe the algorithm itself is not ideal, so that can be the case, because there is no guarantee that if we flip as much. I just had an impression that we still want to first to make as much possible of or ones or zeros, so and then see. But hey, maybe we don't need to do this. Maybe we just need to flip to maximize number of ones in the first column, then maximize number of ones in the second column, right? And once you do this, you just compute. So if this is not going to, Yeah, I don't know otherwise if it's not that easy. Let's see. So I do this, right? Not all once. Binary 1. Oh, but I'm going to say max. 1 and 2. So ideally what I want to see is 15 for the 0 row, 15 for row 2, and 9 for row 1, right? But we will see how it works. And where is the issue? 15 row 2 binary 8 binary 14, something wrong here. Interesting. Let's also yes, it's all ones, so the key matches, and we just lose 1 point here and 1 point there, which is weird because the same function here, what is it, are we changing something here? No. So if it's I, if not this, right, it should go once. Yeah, I don't know. So we set all to 1, right? Then the first time it gives us 1. This too is weird. It's like we're we actually have num here, but it won't change anything. But it's just so weird. It's like we're missing 1 for some reason at the end. All right, yeah. First of all, this. Maybe it will change something. Let's see. And obviously this. Still 38. All right, let's print it out. Almost there. I guess something simple is missing. It's not what we're supposed to have. I would imagine we flip first two columns, right? So 0, 1 is the key. So if we had 1, 0, 1, column J equal 2? Seriously, is this the maximum key? It's weird. Let me see. See out. Max key equal to max key. Oh, it can be actually 2 and 3 in this case. But does it change something if we flip the last two columns? It will make all zeros at the top, all ones at the bottom, so it's all ones and all ones, and then the middle one will be what? Let's say 0 and 1. If you flip, it's, yeah, we just don't need to flip it, so it's the same. It doesn't really matter. Let's see what's the issue here. Max key 2. Can it be? Yes, it is. That's why. Run the code. Should work now. Hey! Yes, it's now 2 and 3. And then we're flipping row 2 and 3. Right. Right, yeah, we make it 0, 1. And we're flipping back 1, 0, 0, 1. So we make it 0, 1, 1, 0. We check both. And basically all we need to do, so we don't need to count this twice. Once we flip it, all we need to say that if, okay, I'll comment this out, I'll comment this out. I doubt that it worked in all cases anyway, but let's see. All we need to say is basically this, right? We can just directly apply it here. So we don't need to waste our memory. So yeah, this I will still count it under 40 minutes. It's just minor refactoring. So if II 0 equals 0, right, then we flip it. And then we say just this. Or actually we don't even need it to be inside this box, right? Because all we care is what we modify. We don't need to do it here. We just say here, binary I to Y. So we assign all ones here. If not, we check if we need to flip it based on the indexes we have, and then we sum and then return. So run code one more time, make sure it still returns 39. and then submit. Obviously it won't pass all of the tests, but whatever it passes. All right, yeah, obviously it shouldn't return, but again, it's just by 1 point. I wonder if I again missed something somewhere. Okay, let me quickly check. So do cout, blah blah blah. It will ask what's the num here. Right. Or actually, alright. Let's just. Oh, we also don't need this one anyway. We don't need this one, I think, and this one. So we need just to say here, row I, binary, and that now equal to this binary, and here, and we also let's and print max key. Right, so basically just to check if it's all ones or not. All ones, then we say binary this, otherwise we say what? Out flipping. We don't need this, we can say flipped. Sorry. Flip row. You can say all ones row, right? Flip row, and again it's just this, and this have else, non-flip row of i's, and then it's binary. Let's run the code, make sure it works here, and then check there. My understanding that it's just the algorithm itself doesn't guarantee us the maximum output. It's kind of best effort. So we didn't solve it today, but that's okay. Oh man. Let's see. So maximum key is flipping first two columns, right? So okay, if you flip first two columns, this will be 0, so it's ones. This will be not. This will be yes. So right now we. But if we flip just one column, we're still using this one, right? Beginning this and this, or we can have this and this. There might be multiple maximum keys, right? So we go with 0, 1, so we flip it, so it's 0, 1. Obviously flipped row will be binary 4 because it will be 1. Basically 1, 0, 0, which is 4. All right, 1, so 1, 7, then 6 in the middle because we flip 2, so it's 0, 0, 1, so we can make it 1, 1, 0. It's 6. Obviously this is 7 again. Then the last one, it was 1, 0, 0, and it remains 1, 0, 0, so it's 4. All right, so now let's see if we have this and this as 7, right? So we flip just one in the middle. So then this becomes 1 0 0, so it's 4. It's 4, so we have 2 4 2 7, and this will be 5. We have 6, and the answer is 29. How on earth you come up with 29? I wonder. What if we don't flip anything? Let's just count. So if we have just one row, so it's 7. This is what? 6 and 6, so it's already 12 plus 7, it's 19. This is 5, it's 24, and then we flip this, so it's 5, it's 29. So yeah, as I said, the algorithm does not guarantee to us that we may achieve the maximum one. So it kind of tries to do best effort. So like in this case, the right answer was basically don't do anything, don't flip any column, just flip rows. Yeah, I just don't know the algorithm itself. Okay, whatever. So with that, let's stop here and see how much test we've passed. At least we passed one test out of 41 out of 80. Okay, so our algorithm, although it's best effort, it passed more than half of the tests, which is fine. And greedy C++. Let's see what the greedy is. J not ij, so we swipe right. So for every row we go, if I equals 0, obviously we flip the entire row. Yeah, that's what we did. All right. That's what we first do. Okay, I see. Then we go for column. So 1 and 0. So we count number of ones and number of zeros. If 0 is greater than 1, then we flip the entire column. All right. And then we just count it. It's actually even simpler than I did. Man, I didn't know that greedy algorithm works here. So the idea was, if we flip to the default scene back, to the whiteboard back, let me undo some of the changes here. Up. Yeah. So the algorithm is super straightforward, but you never know if it's really hard to say if the greedy approach will work here, right? So what's the approach here? So the approach here, basically, you first go row by row, right? Because you don't touch the columns, and you just check if it's 1 or not, you flip it, right? So that's your approach. If it's 0, we flip it, so we make it 1 1 0 0. So this is 1, we don't touch it. Okay, then we go column by column and count ones. Okay, these are all ones, so we don't touch it. Here we have more ones than zeros, so we don't touch it. Here vice versa, so we reverse it, right? And here is the magic happens. So once we start reversing it, and that is 0, right? But again, we count 1 0 0, so we reverse it, and ta-da, we have this, we have this, and we have this, which is actually, I guess, even better than I had, right? So because this is 5, not 5, this is what, 8 plus 2, so it's 10. This is 15, this is 15, so 30, and the right answer was 29. Did I miss something? Let me see. But the algorithm is straightforward. I'm surprised that the simple greedy approach worked here. It was 0, 0, 1, 1. Okay. So we flip it to 0, 1, 1, 0, 0. Then we have 1, 0, 1, 0. So we don't touch it and we don't touch it. Then we go column by column. So here we have all ones. Here we have, because we flipped it now, 1, 0, 1. We don't touch it. So the last column we have 0, 1 and 0. So we flip it here. Yes. So it's yes. So it becomes all ones at the bottom, all ones at the top, and 1, 0, 0, 1. Okay, man. Damn. So how can we prove this always the case? I just interesting in the curious in the thinking process here. So yeah, we definitely know that when we flip the row just by first element there, we maximize the number of the row. This is obvious, but what about columns? All right, man. Yeah, good for that guy. It's really interesting. But hey, our algorithm also sort of greedy, best effort algorithm, but doesn't yield the maximum result. So in my version, I saw that we want first to find all rows that can be made to zeros or ones, because if there are all zeros, you can flip it to one. So this is maximizes the number. And for the residual rows, we just go through them, flip whatever needs to be flipped to make those happen. And once that's done, we just check if we need to flip the rows itself. So it's more sophisticated, but turns out it doesn't pass all the tests. So with that, man, that's bad. And when you don't solve the medium problem, you feel terrible. I mean, when you don't solve the hard problem, or at least come up with some sort of algorithm that passes some sort of checks, it's fine. But for the medium, oh my gosh, whatever. It's Friday, so maybe too much. All right, with that, see you either Saturday or Sunday. Depends.